Good morning, everyone. My name is Mike Clark, and I'd like to welcome you to today's DBA virtual chapter presentation. Today's topic is on removing the risk from important maintenance tasks. Our speaker today is Ed Pollack, and we're looking forward to today's session. And I would like to welcome you all to today's session. Thank you for taking time out of your schedule to attend this class. The virtual chapter is one of many virtual chapters underneath the SQL Pass organization. As you see by this slide here, there's topics in pretty much any area you could be interested in, from big data to Oracle to language-specific things like Hebrew or Russian, and so forth. Whether it's BI, BA, application development, there is a area of focus for almost everything within the PASS organization. And if you have an idea or a desire to have a focus in an area that's currently not there, feel free to contact SQL Pass. There'll be information at the end to do that. And you can go to sqlpass.org and put in a suggestion, and maybe you can actually start it up yourself. One of the other things that is underneath the Pass umbrella is SQL Saturdays. It's pretty much how it sounds. It's basically SQL Server courses and classes on a Saturday. They're both domestic here in North America as well as international. On this slide here, you see there's probably 12 or 13 of them coming up in the next couple of weeks, from Baltimore to Rochester, New York. Woohoo! I think Ed's going to be speaking. Today's speaker for us will be speaking at the Rochester SQL Saturday coming up on May 14th. Shout out to my hometown. There's also stuff internationally, so if you are either international or traveling to international, you can interrupt your vacation and enjoy a SQL Saturday while you're there. But the large organization, or the parent organization, is called SQL Pass, and they actually have an annual summit. It's coming up this year. It will be in Seattle as this year again, and it's the last week in October, basically. And you see here the cost is $1,800 from now until July 14th. If you use this special VC code right here, which is for our virtual chapter here specifically, you'll be able to save another $150. It's a great place to go. I look forward to this event every year, where I get to see a lot of folks that I work with online and interact with online. I get a lot of great training. I learn. It's probably my most dense area of learning in the whole year. I spend a lot of time doing that all year long, but SQL Pass, I learn quite a bit there. So if you have any further questions, you can go to sqlpass.org and click on the Pass Summit icon and get all the information and register. And there's also local chapters. I'm here in Silicon Valley. We have a local chapter here that I'm a part of. They're a great way to kind of do face-to-face connection with folks. If you don't have a group near you, you can go to sqlpass.org, or actually send an email rather to ce@sqlpass.org and possibly start one in your area. And so the Pass is run by volunteers. So if you're interested also in helping it do anything with Pass, whether run a local chapter, help with a virtual chapter, or even be one of the army of volunteers that are needed at the actual Pass conference in Seattle, if you go to sqlpass.org, you can volunteer there as well. But just get involved. The SQL community is large and strong, and there's a place for everybody. And if you're interested, we're on LinkedIn, Facebook, Twitter, and of course the often mentioned sqlpass.org website. But today we're here to specifically get some more training on our life, and so today we're going to hear from Ed on removing risks from our maintenance tasks. And Ed has been around the block a while. He's been working this stuff for 15 years and is in IT, both as a DBA and a sysadmin. Yes, it's not a curse word, but he was a sysadmin. His passion is simplifying and automating, saving time, making anything run faster and more efficiently, which is very near and dear to many of our hearts, especially mine here. And so sharing all of his stuff with the community is a top priority for him. He's done this quite a bit, and we're looking forward to his session today. With that, Ed, I'm going to pass you the screen, and you can begin your presentation.
All right, thank you very much. So today we are talking about risk, and in the things that we do as DBAs all the time, the risk we incur without even realizing it. This is not a session about how to write a maintenance plan or backups or integrity checks or anything like that. We're really just going to have some simple SQL examples and how to make them better and how to avoid very bad things from happening. So what is this all about? What are we going to do today? Basically, we're going to talk about why we're here, what kind of things can break, what can go wrong, how we can deal with those problems, things we don't always think about much, things we take for granted. We'll do some demos for as long as we have, and then we'll finish up. It's that simple. So I'm going to take today with a bit of a philosophy here, and hopefully everyone agrees on much of this. Number one is preventing outages. Whenever applications go down and SQL servers become unavailable, people get unhappy, money is lost, jobs are lost, people are pissed, you have guys in a ring behind you in a circle all looking down your shoulders, and they all hate you for a little while. So we don't want outages. Outages are bad. Preferably, we'd like to get some kind of warning ahead of time when something bad is happening so we can fix it in enough time so that the outage never happens. We need time for that. Time is very important. If you give me a warning that I have a kilobyte of space left on a drive, not much I can do about it. Another important thing is maintenance tasks aren't always mission critical. Our index rebuilds are important. Backups are important. Many of these things that we do in the background are very important, but are they more important than the applications we support? It depends who you ask. Planned downtime is better than unplanned downtime any day of the week. We would definitely rather have something that you plan for and work on than something that unexpectedly makes your life miserable. Working at 2 p.m. is better than 2 a.m. always. If you can fix a problem at your leisure, that is far superior than being woken up groggy and unhappy at a strange hour of the night. And if things do break, it's a chance to improve. All that we're talking about today are things that I've seen break in the past, make my life difficult, but the things we can improve upon and prevent in the future. So with that little bit of philosophy, let's go on. What kind of bad things can happen? We do lots of maintenance out there, and during our maintenance, things can happen. We could fill up a data drive, we could fill up a log drive, we could fill up a backup drive. When disk fills up, we can't do much, and that's a problem. A job could run very long, unexpectedly long, so that it runs into our workday and interrupts things that we don't want to be interrupted. It could have multiple maintenance jobs overlap, interrupting each other. It could have one job hog a ton of resources, making everything else slow and sluggish. There's a lot more than this can go wrong, and I'm sure that you have experiences in things going wrong. It's part of our world in the database land, that things break and go wrong. So if you could think of more, good for you. I'm sure we all have a lot more. What can break? Well, any kind of data collectors, reporting processes, ETL data movement. Obviously, you're moving data around. You could fill up a drive. Index maintenance, lots of disk usage, lots of log growth. Backups, do you have enough disk space for them? Are the databases online? Are there any little things that we're missing? Archiving, again, lots of data movement, means things can break. CheckDB can take a long time. Monitoring, we build lots of monitoring processes. We have third-party vendor apps. We have our own apps that we build. And who knows what sorts of things can break as a result of things going wrong. And software releases are huge. We release new versions of software all the time. And it's possible that one of those little changes in there causes havoc. So a lot of things can break. A lot more things can break than are listed here. What can we do about it? What can we do about things breaking? So basically, we can go through some examples today and talk about some of these. And you can use your imagination to do even more. We can build checks into our maintenance jobs so that before we jump in and do something, we check first and make sure it's okay. By checking resources before doing things, we can at least make sure that we're not going to fill up a drive ahead of time. So instead of filling it up, we'll tell people, hey, you're about to fill up a drive, don't do that. Use try-catch when you can. If you have any really sensitive pieces of code, put try and catch around it. Therefore, you can catch errors and deal with them gracefully rather than having things fail in the middle of something important or leaving inconsistent data or so on. You can have a parallel job that kills long-running jobs or problematic jobs or things that are going wrong. You can monitor for specific instances of bad things and stop them. Effective monitoring and alerting is huge. Knowing when things are bad before they're bad is important. I'd rather know that a drive is down to 50 gigs free this morning and deal with it than be given an alert a few days later saying you're down to 10 kilobytes and you're doomed. Don't want that either. And as a result, we really can be proactive and reactive. We can look out for stuff before it happens and fix it proactively, and then also check along the way, and if we see things are starting to go bad, stop ourselves before they go really bad. So we're going to jump right into a demo. Much of what I want to talk about today really has to do with illustrating how this works. And I'm going to use, for a good chunk of our demonstrations, index maintenance. Because index maintenance is something that's at the core of database performance. If your indexes are never rebuilt, if they're never reorged, if we never keep them clean, things will slow down over time. So this is important to us. And so I've built a relatively straightforward index maintenance proc. I'll walk through it very fast. Again, the important key here is that the specifics of these procs are not really what we're all about today. What we're really going to be talking about is how to make them better. So I'm going to show you some very simple procs that do index maintenance or backups or whatever. Don't get hung up in the details. The only real details I'm going to focus on will be the changes we make to make them better. So we pass into this proc here a little bit of information about at what percentage fragmentation should we reorg an index or rebuild an index. And then if I want to, I can give it specific databases or objects to act on. And so ultimately, this proc uses dynamic SQL, goes in, and if you pass in no parameters, it'll defrag all the indexes in every database based on those percentages. It uses dynamic SQL to jump through, get data on the indexes, and then do the alter index statement. Again, it's 100 lines of SQL. It's meant to be very simple compared to what you could be writing, index defrag proc. And I could run it here on all of my databases, but just as a demo of it, we'll just go ahead and build it. So now we have this proc, and now we'll just run it. There's no checks or balances in here. We just run it, and there we go. Returns a little bit of information about what it did, and we know it completed successfully. And so it rebuilt or reorg indexes on AdventureWorks, which we'll be using today, and country region, that table. Pretty straightforward. But I didn't build any checks into this, and I'm not sure how many of you have dealt with this, but something painful that can happen to us is you run through a process one night of rebuilding indexes, and you run out of disk space. Your log drive fills up because there were lots of indexes to rebuild. A lot of change occurred in production recently for whatever reason. Maybe you had a big release, maybe you had a big data import, who knows. Something happened, and your drive fills up. You get woken up at 2 in the morning because your log drive filled up and things aren't happening in production, and it's because your index rebuild proc. And so now we as DBAs are at fault. Something bad happened, and we're stuck cleaning it up, and anybody who uses that application is unhappy because they couldn't do things for a little while. So we want to prevent that. We want to be able to check our disk space ahead of time and validate, is there enough space available for us to do what we need to do? So we're lucky. Microsoft gave us dynamic management views that can help us get information. So this little query right here checks DMOS volume stats. This DMV was released, I believe, in 2008 in one of the service packs, and it gives us a little bit of information about the drive that a file lives on. So if I were to run this, I'm currently in AdventureWorks 2014. If I were to run this query right now, I get back 59 gigs free. So the drive these files live on, which is my C drive, has 59 gigs free. So if we know that, and we know that we're altering indexes, and we know how big those indexes are, we can get a bit of a guesstimate as to how much space we're going to need when we're doing index operation. So what are we going to do here? I'm going to walk through some of the changes I added into my proc here, and we're going to walk through it and run it, and then talk about it a bit. So everything here is the same. It's a lot of SQL to introduce in one shot, but I'm only going to really focus on what changed. For the most part, everything's the same. All the SQL about what databases, tables, indexes are being touched is the same. What we're adding in, though, is a piece about free log space. I have an additional parameter up here called log space free required. You can pass this in however you'd like, but I'm saying, hey, I want 100 gigs free at any time during this proc. If at any point in this loop, when I'm rebuilding index after index after index, if the drive runs under 100 gigs free, we want to stop. If the operation we're going to take is going to put us under 100 gigs free, we also want to stop. Either way. So don't even jump in if we think we're going to be going under 100 gigs free. You can alter this to whatever value you want. It doesn't matter to me. But I'm using 100 gigs for the sake of argument here. So now we go past all of the data gathering that we did before, and we have a little bit of dynamic SQL here. So we're going to go in, and we're going to basically get the log space, and we are going to generate an error message. So we're going to use the database that we're in. We're going to find out how much free space is in the drive using DMOS volume stats. And then once we have that information, we can go ahead and say, hey, here's an error message about what happens. And in the event that the free space we have minus the size of the index happens to be less, then we're going to have to go ahead and raise an error, return, and get out of there. And that's pretty much it. That's the only thing we really added was a check here for log space. Everything else is exactly the same. So let's go ahead and create this new version of the proc and run it and see what happens. So let's say I want to run it on our index like before. I run it, and I get an error message. Hey, not enough free space. As I showed before, I have 59 gigs free on my C drive, and 59 gigs is not 100. So because it's less, and because touching this index would bring it even lower, it throws an error, it exits, and we're done. I can change that threshold if I want. So for example, let's say I'm willing to tolerate 10 gigs free. I run it, and it completes successfully. So let's talk about this a little bit. Whoops. Let's talk about this a little bit. So what happened here? Well, index operations take up log space. We know that. And we can check it before our work, though. And by using index size as an estimate of usage, and this is totally an estimate, you can estimate higher if you're more conservative and you want more free space, or you can estimate lower if you want to live on the edge. I'm just using index size, though, as an estimate of how much space will be used when we perform an index operation. And so we can automate this and tell our proc to do all this work for us. If space is low, throw an error, and get out of there. How you want to alert's up to you. I raised an error here, but you're more than welcome to email or write to an error log or to a text file or text me, call me, whatever. That's totally up to you. The theme here, though, is that this proc can do all the work for us. It can check ahead of time as we're looping through indexes and defragging them and tell us we're out of space or we're going to be out of space and we'll be in trouble. That's the theme of what we're talking about today, is being proactive and thinking ahead and preventing bad things from happening. Because realistically, index rebuilds aren't going to fill up your disk very often, but you'd prefer be never than not very often. So that's our first example here on how to improve our maintenance procs. We use disk space as an example, and this is one way of preventing bad things from happening. But we can do some more things as well. We can do some additional work. So other things we're interested in addition to disk space, are what time is it? Should we be running this job right now? If it's between business hours, I probably don't want to be touching our indexes. And so we could just write a very simple, declare a few variables, check the time, and if the time is within our business hours, again, throw an error and get us out of here. If I ran this SQL right now, I'm checking to see if the current time is greater than 7 a.m. or less than 1 a.m. So basically, I want to run index rebuilds between 1 and 6 a.m. only. You can change these times to whatever you want. This is totally customizable, but in general, we as business people have times we'd much rather be touching our databases and doing maintenance than not be. And so we can very easily check and see if we're within a good time period or not. We also could check the job runtime, and we can do this using some information from MSDB. But in general, I could structure it like this, and I could say, hey, what time did the job start? And if the overall runtime of the job is greater than some amount of time that you define, throw an error and get out of here. In this case, I'm just saying 6 hours for the sake of argument. If this index rebuild job runs for more than 6 hours, get me out of here. Something's wrong, or it's running for too long, or we're going to probably hit business hours soon, or something. So this is a great way to deal with long-running jobs. And we can get information about job history from sysjobActivity and sysjobs, which are system tables within MSDB. and it tells us all about our jobs, when they've run, and so on and so forth. So what can we do with this information? So before we took our disk space check and put it into our loop and said, hey, check disk space, are we okay? We're okay. Go ahead and run an index rebuild. We finished the first one. Are we still good on disk space? Yep, we're good. Keep going, keep going, keep going. Same thing here. So we're going to add into here, and you can parameterize any of the stuff you want here. I'm just trying to keep these examples as clean as I can, given that dynamic SQL is not exactly clean. I'm trying to keep them as simple as possible. So everything here is essentially the same as before. We're getting databases, we're getting listed databases, we're going to perform index maintenance on them, we're gathering index data, and here's our free space information from before. We're going to check our disk space just like we did previously, and if it's unacceptable, get us out of here. We're going to do some additional checking though in here. So in the same loop, we're going to also check to see, hey, what time is it? Is this job exceeded the maximum runtime that we want it to take? And if so, get us out of here. And all it's doing here is just checking the job start time. We grab that up top. So we know what time our job started internally. And we can say, hey, if that the time between that and now, greater than 6 hours, get us out of here. This is not good. And so it'll raise an error, return, get us out. You can also check the current time and say, hey, once again, is the time between 7 a.m. and 1 a.m.? If so, get me out of here because we have people getting ready to do business. Our databases are going to get busy, and I don't want to be defragging indexes when error peak operation time. So just like before, select an error message, it's descriptive, provide a little bit of information about what time, what happened, raise an error, and get us out of here. And then if all those checks pass, then alter the index and continue. Everything else after that is the same as before. So let's go ahead and create this. This proc is exactly the same as what we had before, plus these additional checks for runtime and for time of day. So if I were to go ahead and run it on here, I get an error message immediately. Even though I specified 10 gigs free is okay, and run it on this database and on this table, I get an error message saying, hey, this job is running outside the allotted maintenance period because currently it's 12:24 p.m. Eastern Time, and that is not between 1 and 7 a.m. So I tried to run my index proc, and it failed. You could easily, if you wanted to, parameterize these hours. For example, 7 a.m. to 1 a.m. be parameters you pass in to, kind of dynamic, make the start and end times whatever you want. Same for duration. If this proc were looping around for 6 hours or more, it would have thrown a different error saying, hey, it exceeded 6 hours. But anyway, it's 12:25 p.m. and I'm not allowed to do index rebuilds right now. If you were in the middle of running this operation at night and it kept going for a long time and it hit 7 a.m., it would also stop for the same reason, because we've run over. So what's all this about? We're really controlling job timing here. We're checking the current time and making sure that we're okay. What time is it right now? Is it during our hours we're allowed to do maintenance? And so we can do that check anytime we want. So why not do it in the middle of a loop when we're going through indexes one at a time? And we can parameterize whatever we want, as I mentioned. And what we do based on it, though, can be really whatever we want. I raised an error here, but you could alert, you can kill a job, you can email, text, page, Snapchat, I don't know, whatever you feel like doing, you can do that based on this information. And for the record, I do not necessarily recommend Snapchatting from SQL Server. I'm not sure how you would do that, but I'm sure it would be fun. Anyway, this demo interrupts reactively, and it's important to differentiate between us being reactive and proactive. So far, everything we've done has been reactive. We check something, see if it's bad, and if it's bad, get us out of here. But in theory, we could be late. It's possible that something could have run for a very long time, and it finishes, and now it's 9 a.m., and it kicks us out. Not the worst thing in the world, but it's not great. And so it doesn't protect us against everything, but it certainly helps us a lot. We can do a little bit more, though, I think, than this. We can get proactive, and we can check and see, while something is running, if it's exceeded certain parameters and get us out of there. So let's talk about being proactive. we're going to put in a parallel job. I'm going to create a parallel job just called job verification. And I can, in this case, pass it in some parameters such as log space free required, a job to check. You can customize this however you want. You can have it check all jobs, no jobs, some jobs, whatever you want. You can have it check other things as well. Again, I tried to keep this simple, but you feel free to integrate this into your business logic, whatever you need to fit your needs. So this verification job is going to go and do a lot of what we did before, but it's going to do it separately. It's going to go out there and it's going to check log space, and it's going to throw an error if there's not enough space available. It's going to check start time of a job, and this time it's going to go out to MSDB. Previously we were in a job, and we knew what time it started because we did it, and we could differentiate between the start time of the job and the current time, subtract them, and find out how much time has passed. From a parallel job running separately, we don't have that luxury. So we need to actually go in and figure out from MSDB, what job is running long. That's our job to check, and skip the one that we're doing right now. This job is actually called job verification, not the job that verifies. That's fine. Verification job. And again, throw some errors. So if it exceeds the maximum time of 6 hours, throw an error. If it's running during business hours, throw an error. And as a bonus, I have a little flag here, stop job. And basically, if anything switches that flag to 1, we come down here, and one last piece of code executes, where we'll basically find out, is there a job running still at this point with the job we're interested in, that job to check? And if so, run sp stop job, kill the job midstream, be done, and then raise an error. So we're going to basically raise an error out of this job, this parallel job, but as a bonus, we're going to stop the job that's causing us trouble. And so this job could be in the middle of a loop, it could be doing anything. And we'll kill it midstream and be done. So I've already created a job for this. We'll create this proc. And I over here have index maintenance. This is a job I've already created. It goes and executes our proc from earlier. It just runs it in an infinite loop. I don't want it to finish its work while we're demoing this, so we'll let it run forever. That's fine. I didn't give it any specific parameters, so it'll keep rebuilding indexes indefinitely, or trying to, and that's great. Here's a verification job. You could run this every 5 minutes, every 2 minutes, every hour, whenever you want, really. Again, this is up to you how you want to run and check for things in your environment. All this job does is execute the proc we just created. And that proc's going to go out and check and make sure all of our conditions we talked about earlier about disk space and run times and what time of day it is. It's going to check all those things, verify they're okay, and if they're not okay, kill the job. So let's go ahead and demo this. Let's go ahead and, oops, let's grab this, put it here. Let's run our index maintenance job. There we go. Index maintenance job is running. It's in progress, and because I put it into an infinite loop, it'll run forever, which is great. Now let's say I run the verification job. I hit start job, and we run the verification job. It runs, it fails immediately. Why did it fail? Well, the logs will tell me. Verification job failed, and the reason it failed was job is running outside the allotted maintenance period. Job index maintenance stopped successfully. Nice. That's what I hoped for. And we can see over here that index maintenance job, it says success. I suppose it succeeded to fail gracefully. But it succeeded in failing, and it was canceled. If we check our log, index maintenance was canceled. Job was canceled as a result of a stop job request. Cool. So our verification job said, hey, we're running not between the hours of 7 a.m. and 1 a.m., sorry, 1 a.m. and 7 a.m., and therefore the job got killed. And so even though I might have been in the middle of touching an index or doing something, it stopped it anyway. So let's talk about this. This is kind of a neat piece of functionality, because we can now proactively monitor job performance. We can look around us, and we just monitored a single job here. I use this parallel job to go out and monitor index maintenance, and if certain things happen that were not good, kill the job. We can really proactively monitor anything. There's really no limit. You can monitor any situation on your server you want proactively, and if a bad situation arises, you can take an intelligent step. Maybe you don't want to kill the job, but you want to send an email, or maybe you want to get a phone call or a page, or whatever else your organization uses to contact you. This allows you to take a job that's misbehaving and doing bad things and stop it right immediately, because you may not always get to the end of that loop. For example, let's say you have a humongous index you were rebuilding, and it could take 4 hours to rebuild, and now it's 8 a.m. Our initial work that we did would have only realized we're in trouble after it finished, and it's past 7 a.m. But this job will stop at midstream. It'll say, hey, it's 7 a.m., there's still a job running here, I don't want to be running, kill it, done. We can check any metrics we want. We check the same 3 metrics we've used so far. Disk space, we've checked the runtime, and the hours of operation. You can check anything you want. There's really no limit. If your imagination can think of it, you can probably write it in T-SQL. And this prevents infinite loops. It prevents jobs running forever. It prevents unacceptable things from happening that are beyond our control from within the code of a proc or a job that is stuck running for a while. If you combine this with what I showed you earlier, you have proactive and reactive monitoring. Then we have the ability to pretty much stop something if bad things are about to happen or while bad things are happening, and pretty much can prevent bad things from happening. So this is very useful, this idea. And we can take this and we can go a little further. There's a limitation in the disk space DMV that we talked about earlier. I introduced DMOS volume stats as a great way to get information on your disk. This is useful, but at the same time it's a little limited in that you can only get volume stats info for drives in which you have files on them. A log file, a data file. If you don't have some sort of SQL Server file on there, though, you don't have any visibility, and that can be a problem. And so I can run this query here, and I can say, oh, my data drive is on C, and I have 59 gigs free, just like earlier. I can get file info. But let's say you had a backup drive or a different drive that had no files on it. How do you get disk space? There's a lot of options available. You could use PowerShell, you could use an OS command shell batch kind of thing. You can use XP command shell. I could run XP command shell dir C:, and get back that I have that many bytes free. XP command shell is not very popular though. It's very useful, but not everybody wants to use it because you're giving SQL Server OS level disk control, and that's potentially a security hole. So if your organization's okay with it, that's cool. Keep your security tight if you can. But if you're not okay with XP command shell, what do we do? Let's say we have a drive and we have no data files on it. Therefore, DMOS volume stats is not useful to us. Let's say we don't want to use XP command shell, and for whatever reason you don't feel like using PowerShell or something else. You can kind of cheat, and I'll give you a cheating option here. And you can be the person to determine whether this is cheating or being snazzy and witty. Up to you. But I'm going to create a new database, and you can put this anywhere you want. Let's say, for example, the C drive doesn't have any data or log files on it. I can create it on there right now. So this database is just called dbtest. It's not very big or special. Gave it a data file, gave it a log file. That's about it. And there it is, dbtest. Awesome. Now that I've created a dbtest database, I can use dbtest, and I can run our query from earlier. And so no matter what drive this thing is on, I now have insight from DMOS volume stats. You may not be okay creating a database on a random drive somewhere, but this might be a useful hack that will allow you to basically get the ability to see disk space in a drive through the DMV without having to use XP command shell going out to the OS. So this may be something you can use. This may not be that useful, but I figured I'd introduce it here as a possibility because it's kind of cool. All right, so let's jump back. So we're really just cheating DMOS volume stats. I created a little dummy database on some drive of interest. It could be a backup drive or some drive we don't have any databases on. But once it's there, you can go into that database, you can create a DMV and get all the volume stats info you want using that DMV. It's kind of snazzy, it's kind of cool, it's sort of cheating, but depending on who it is and who's using it, you may like that, so there's an option for you if you'd like it. Let's talk about backups and use this kind of in a more applied method. Backups are something where we can fill up a drive. And again, we might have our own monitoring out there that says, hey, your drive is running out of space. That's not good. Stop, it won't stop anything, but we have our own alerting systems. And so you might get an email at 2 in the morning saying, hey, your backup drive only has 10 gigs free. Good luck. To which you're groggy and tired, and you stumble on your computer. And if you're lucky, you can stop whatever's happening before you run out of disk space. That's not very fun. I wouldn't really enjoy doing that, given the choice. And so you want to work in your jobs and your procs into that so that you have the ability to kind of let it run itself. So again, we're creating a very simple job here. It's, 50 lines of SQL. It's a very simple backup plan, nothing fancy. All you do is pass in a backup location. You can pass in a database name if you want, and it'll back it up. That's all it does. Backup database to disk. A little bit of dynamic SQL. It skips out in system databases, but ultimately it's just backing up databases. It's pretty dumb, but that's all I really wanted here was something simple. So we can go ahead and use AdventureWorks and put this job into place. And here's our backups folder. It's empty. I can go ahead and run a backup on AdventureWorks using this proc. I have it print out the SQL as a reference, and it runs and it finishes. And if I go back to SQL backups, there it is. There's my backup created just now. Sweet. So we have a backup proc. Unfortunately, if I were about to back up a 60 gig database, that would be unfortunate for me because it would fail. Either it would manage to squeeze it onto the disk, in which case I'd have no space left, and that would stink, or I would just throw an error saying I'm out of disk space, good luck. Either way, I don't really want that to happen. I want to be a little bit proactive. So let's alter this job in the same fashion we did earlier. Now, I'm going to assume for the moment that we're going to use that DB test to get backup drive space because I put those files out on this C drive. If you have a database file out there, you can go out there and use DMOS volume stats to get your disk space. If you don't, you can use XP command shell, you can use PowerShell, you can use some other step in a job. How you do it is up to you. The generic method, though, is really what I'm focusing on here. And so the really only thing that matters here above anything else is that this job is the same as before, but before we run our backup, we're doing a check here, and we're saying, hey, get the free space on the drive, check the size of the database that we're going to be backing up, and if the backup drive free space minus the size of the database would bring us below the space that we want to have free, throw an error, and get us out of here. So we're passing in a parameter of the free space required, very similar to earlier. So let's go ahead and run this. Everything else is pretty much the same. Let's run this demo. So if I were to just go ahead and run it and back up the database, it runs successfully because I have enough free space available to run and create our backup file. But let's say I were to put in a parameter and said, hey, I really want to have 9999 gigs free all the time on my backup drive. It's a lot, but let's say I were to do that. We can make it less, I guess, and be realistic. Let's say I wanted 99 gigs free. If I were to run it with this parameter, it's going to go and check and see 99 gigs free now, and will I have that free after I back up this database of size blah, whatever that size is. I run it, and I get an error. The error is not enough free space available to process the backup. 58 gigs are currently free, and stopped. The beauty of this is now that we can check the free space on the backup drive before running the backup and seeing if we have enough free. And if we're about to run ourselves into a bad position in terms of space, throw an error, send off the email or the phone call or whatever it is you need to alert you. But the nice thing here is that you're being alerted of a problem that hasn't really quite happened yet. The backups didn't finish, and that certainly is bad, but we didn't run out of space either. And so other backups, such as perhaps T-log backups, may continue happening, even though this full backup couldn't finish. You as the operator can now go in and deal with the fact that the drive is filling up, but the drive isn't full though. And you can make this free space as high as you want. You don't have to even kill the job either. If you wanted to, you could just put a warning in here and say, send out an email to the DBAs that says, hey, we're running low on space in here. We'll keep running backups for the moment until we get to a certain point, but you should really do something about it. And so how you monitor is very flexible. And you can have it kill a job, you can have it warn you, alert you, whatever you want, based on whatever threshold you want. So this is a good demo of just kind of how to take a backup job, make it a little more resilient. Oops. All right. So what happened? Backups, as we know, can consume a lot of free space. And we can check space via a whole bunch of options. I use DMOS volume stats, and I demoed XP command shell, but there are other options available. You have PowerShell, you have Windows monitoring tools, you have third-party vendor software, you have your own tools that you've built out there to monitor disk space. However you do it is up to you. What I'm advocating for is monitor for free space and alert when bad things happen, but be willing to stop a job gracefully in the middle rather than let yourself run out of disk space as a result of something bad happening. I would much rather be in control of a job stopping than have it stop because we're in deep trouble. And so you can add checks into the backup job like we just demoed, or we can put steps into that parallel job we talked about before and have it check backup space for you. Those are both options, and they both will allow you to go ahead and check space, see how things are going, and take customized actions rather than getting in trouble. All right. So we're going to kind of conclude, so we have a little bit of time to answer questions and talk what we did here. The important thing here is we can monitor a lot. I gave some demos here, some quick demos on index maintenance and on backups. But here's a long italicized list, almost here for comedic effect, of things you could monitor if you want. Depending on your organization, depending on your application, and depending on what it is you do, there'll be certain metrics that mean a lot more to you than others. Perhaps you have tons of disk space, and disk space isn't really a big deal for you. Maybe CPU is a huge deal for you. Maybe waits or deadlocks are a big deal for you. Maybe memory usage is important. Whatever the metrics are that matter to you, you can monitor them. And I'm sure there's a lot of things I did not list here that you could monitor if you want. So we can monitor a lot. And the key to make life easier is to look before leaping, but also look while leaping and after leaping. And so whatever jobs you're running, whatever maintenance procs you're running, whatever it is you're doing out there, make it a point to check available resources before doing things. And if you think necessary, check while you're doing things. And even afterwards, check and see how you're doing afterwards. By keeping kind of a consistent lookout on this, you can kind of have a good idea if things are okay or if you're in trouble. Given the choice, I'd much rather get a little email at 8 a.m. saying, hey, you're kind of running low on disk space, than get a phone call at 2 in the morning from some angry person because things broke. You can also target things that you know are particularly bad. If you have a very specific thing that bothers you all the time, fix it. A habit we fall into sometimes as DBAs that kills me is you'll wake up in the morning and there's a drive that's almost out of space. You'll go and shrink all the log files and get back to work. Next day, you wake up, go to work, and the drive's low in space. You shrink all the files, get back to work. And you do it over and over and over again, and it seems like you're wasting a lot of time doing manual things. A big piece of what we're talking about here today, what we did, is trying to automate this process so that things fix themselves a little better and that you solve a problem once and for all. We don't want to do manual work. We don't want to be fixing things every single day or reacting to expensive mistakes. This allows us to take costly tasks, expensive ones, separate them, manage them better, know what we're doing. A big piece of this as well, in the work we do, is we can consider new technology as well. When we did our work today, I kept things pretty straightforward. DMOS volume stats is a somewhat newer DMV, but in general, everything I did here today you can do on your system in any version of SQL Server, so you don't go back too far, and it'll work. There are other ways, there are other tools out there you can use that might help you when it comes to monitoring or improving the performance of things. And so always consider new features as well. You know, monitoring isn't all it takes to fix a problem. If your backups are huge, maybe compress them. If you haven't used backup compression before, it's a great feature. Look into it. So consider new features when trying to improve your processes as well. And I say impress your coworkers, but it really is about making life easier for everybody. You don't want bad things happening in a production environment. You don't want things breaking unexpectedly, certainly. And you don't want to be doing manual work all the time, fixing things that break when they break. And so, trust your coworkers. What I'm really saying is make your life easier and make theirs easier. Make people be able to focus more on their actual work, on developing cool solutions, and not responding to alerts and problems and broken things. Because a lot of the things that break, whether they be very much database administration style things like disk space or memory usage or whatever, or application things like some control table somewhere got too big, or some application problem arose. Respond to these things ahead of time. Look ahead before you leap. Always check things ahead of time and make sure things are adequate before you do them. So I'm saving a little bit of time here for questions at the end because I think we may have some, and I don't want to run over. And so at this point, I think before I conclude, I'd like to throw it out for questions and see if anybody has anything they want to ask about all this stuff that we kind of blitzed on through today.
Wow, Ed, thank you, man. That's a really good overview of some how to keep ourselves from getting caught out in the weeds and repetitive kind of tasks. I like how you've done that. That's given me some ideas. I appreciate that. I want to point out, we do have a couple of questions, but I really want to point out some things that I thought were pretty cool. I love a couple of your quotes that you prefer never over not very often. Once we stub once we get that call late at night on something, we don't want to get that a second time. We're in a hiring binge right here, right now, and training a couple of new guys. And so I basically have told them, if I get a call at night, it means I did not do my job during the day. And you just spent the last hour kind of emphasizing that same thought. We don't want to get called at 2 a.m., get groggy, get whatever. We can be very smart about what we do, and I love the way that you've handled that. Given that, we do have a couple of good questions here. One of the questions is the procs that you have here. You're talking about. Do you suggest putting those into into like master database or a separate SQL admin, custom database, DB admin database kind of a thing?
Good question. Personally, I'm a big fan of leaving master clean. To me, master is a system database. It's part of SQL Server. It's very, very important. If master breaks, your server breaks. I'm a very big fan of creating your own customized DBA database. Call it whatever you want. Put your procs in there and run them. I put them in AdventureWorks here because AdventureWorks is a nice place to demo from. But feel free to create your own database, database administrator tools or DB stuff or whatever you want to call it. And I'd recommend keeping all of your own procs and metadata and whatnot in there. That way you separate it from important system tables and databases, and you also separate it from your application, which is another separate environment altogether.
Yeah, that's a good strategy. How would you estimate the amount of space that a compressed backup would take? So if you want to put, how much free space to have for your backup drive and so forth.
Okay, so when I did my work here, I took the database size as my estimate. If you're compressing backups, then I'm estimating a little high. There is no perfect way to guess. I've tended to guess about 20 to 25% for a compressed backup. That's just a guess. Again, I would rather overestimate than underestimate. I don't want to run out of space by accident if I'm wrong. And so I'd recommend overestimating. If you want to use the database size for a backup to guess how large it'll be, that's fine. But it's kind of big. I'd say maybe 25 to 30%. Go higher if you're a nervous DBA like me. Personally, I would go very high. I would say 50% maybe, or maybe 40%. Again, you don't have to, but I would much rather be on the safe side than on the sorry side of being woken up at an hour and not very coherent.
Yeah, that's conservative and not having it woken up is a good plan. Yeah. Another question here is, I'm just going to read it here because so it seems that a good DBA wouldn't necessarily use the GUI items from the toolbox for maintenance plans. Do you still need to run and update stats after an index rebuild reorg?
So if you're updating, So you're comparing updating indexes by defragging them versus updating stats. Is that what the question is? Whether
Yeah,
index still updates statistics?
yeah, I think the final question is: do you still need to run an update stats after an index rebuild reorg?
So the first half of the question was about, would you prefer to use a maintenance plan or a store procedure? It's very much up to you as a DBA. The one benefit of creating a store procedure over a maintenance plan is you gain a lot of flexibility and can do whatever you want and build in whatever monitoring you want. When you rebuild an index, the stats on that index will get rebuilt as well, so you wouldn't have to worry about updating stats on it. If an index is not rebuilt, then the stats won't necessarily get updated automatically by anything else. So it would depend on whether or not the index was rebuilt. So we have a separate process to handle statistics being rebuilt. It won't have to necessarily rebuild those on indexes that were rebuilt, but it might also know that already. It would probably check to see if they need it before doing it.
Right.
I think that answers the question, I hope.
Yeah, you got both of them there. Yeah. Another question is in your example of calculating free disk space, what if your log file has, like, say, 15 different files? That particular function looked like it took a database name and a file ID.
In that particular example, I joined master files to DMOS volume stats. The volume stats DMV gives you the disk space free on the entire drive. If you wanted to get specific file size, you can go into the sys database files or a couple other views out there and grab information about each file. But the DMVs I show give you the entire drive free. So if you're interested in finding out how much space a drive has free, use DMOS volume stats. If you're interested in knowing how much space a file is taking up, that would be a different view, a different operation, and you can very easily find that SQL online. Microsoft doesn't hide that, so it's pretty easy to get a hold of. But those are separate. You can join it all together and get all the data in one data set, and it tells you how big a file is, as well as how much space is free on the drive that it resides on.
Okay.
And feel free, I give my contact info at the end of this after the questions on my next slide. Feel free to contact me if you have any questions or looking for some demo SQL or some ideas if I didn't fully cover it. I obviously can't pull up Management Studio and begin writing queries right now, but if you have any additional questions or ideas or thoughts, feel free to find me online and we can chat.
Well, Ed, if you could advance to that slide so folks could get that information here while we're still going through the last couple of questions, that would be good. Thank you.
Sure. There you are. There's me. I'll go through it at the end.
Yep. So a question here: when you were in your demo, like if your index job was going too long and you had to force it to stop, the question is a follow-up question to that: if the index job is killed, does the work that it does until that point get saved? And what happens if you start the job again? Does it pick up from that point or what? Just if you could clarify that.
Good question. If you're reorging an index, it's kind of a process that goes and goes and goes. And if you stop in the middle of a reorg, it will save. The progress is saved because it's being done in place. So whatever you've done and accomplished so far will be done. You won't advance any further. But whatever's done is done already. When you rebuild an index, you're essentially creating a copy of it and then killing the old one. So if you're in the middle of an index rebuild and it gets killed midstream, then the work on that one has been done. In the example that I gave, we went through a loop pretty much and said, rebuild all the indexes in a loop, on a database, on a table, on whatever. So anything you've rebuilt before that will be done. So if you had 10 indexes to rebuild, and you went through and we were rebuilding them, and then on the 8th index an error was thrown because we're running low on disk space, that 8th one would roll back because to rebuild. If it were a reorg, it would just stop in the middle and be done, and you'd have some progress. The previous 7 are done, and they're good. And the 2 you never got to, we never got to. So they wouldn't have happened.
Okay, Ed, with that, I think we're kind of run out of time here, so I wanted to pass it back to you so you could finish up your contact info and any closing remarks.
All right, thank you very much. I know I went through this all very quickly. I love presenting lots of information very quickly, lots of SQL examples. If you have any questions about the information, it's all available afterwards. Take a look through it. Let me know what you think. Again, The examples given were not meant to be the perfect maintenance jobs. Please don't just copy and paste them into production. They were meant to be simple examples of how a backup job or an index maintenance job could run. You'd probably want a lot more customization, though, before you put something like that into a real environment. So here's my info. At Pollock, you know who I am. I have my email address, my Twitter handle. I have some links here to places that I've written articles, such as SQL Server Central or SQL Shack. And this is my own personal little plug. I'm coordinating the SQL Saturday out in Albany, New York. So if you happen to be anywhere near Albany, New York, on July 30th, click on the link, check out our SQL Saturday, come visit. It's beautiful out right now. It's beautiful in July. It won't snow. So please come. And thank you very much for joining us today at noon on a Wednesday. If you have any questions or anything else, any suggestions about the presentation or anything else, feel free to contact me.
Okay, thank you once again, Ed. And everyone else here, I want to let you know that these slides and the audio, the full recording will be available on dba.sqlpass.org in the next day or so. So if you wanted to catch up and re-listen to something or watch something again, you can do that. And the actual slides, the actual presentation and code will be available for download as well. Once again, thank you everyone for coming, and see you the second week of next month.
All right, thank you.